Hello, welcome to another tutorial from Smart Learning with Sati. And in this video, we'll be continuing from where we stopped in our previous video on differentiation from first principle. So if you haven't seen the part 1 of this tutorial, I'd advise that you check it out on my YouTube channel under the playlist Introduction to Calculus, and you'll find it there. And if you recall very well from the first part of this tutorial, we saw the definition of differentiation, and we saw how we could determine the gradient of a straight line, which is change in y over change in x. In this particular tutorial, we'll be looking at how to get the gradient of a curve, which will lead us to deriving the formula that we can use to differentiate any function using first principle. So what we have here is a quadratic graph, or we can say that this is a graph of a quadratic function where we have our x-axis and our y-axis. Of course, we know that y is a function of x. So how do we get the gradient of this curve? How do we determine it? This is going to be slightly different from how we get the gradient of a straight line. Now, what do I mean by that? So let's take 2 points. Let's say A here and B here. I want to find the gradient of the line that connects A and B. So this particular curve that runs from A to B. So we want to get the gradient of this. Now to do this, we can simply connect a line from A to B like this. Now just from observation, if we take the gradient of the line AB, the line we just drew here, A and B, it won't be exactly the same with the gradient of the curve that goes from A to B, because they are not on the same line. If you observe, if you watch closely, so what we're going to have is an approximate value which is actually not very close to the original, to the exact value of the gradient of the curve. So that won't suffice. So what do you think we should do? Now what if I reduce the distance between A and B in such a way that I have A1, let's call this A2, and I have B2. So I've just reduced the distance. And if I draw a straight line that connects A and B, of course, they are not exactly on the same straight line, but it's actually closer than when we have the initial A and B, if you observe closely. So what does this tell us? It tells us that as we reduce the distance between A and B, we are going to actually have a value that is closer to the gradient of the curve. All right. So that means to get an accurate value for the gradient of this curve, we have to keep reducing the distance between A and B until we get to 1 point. So this is what I mean. So instead of taking 2 points on this curve, what if we just take 1 point here? Let's say this point here. Let's call it P. And we are trying to find the gradient of this curve at this particular point. Now to find the gradient of this curve at this particular point, we simply have to draw a line that will touch the curve at that point, something like this. And this line is what we call a tangent line. A tangent is the line that touches a curve externally at 1 point. So we can now see that the gradient of this tangent line we just drew here is also equal to the gradient of this curve at point P. So having established that fact, let's go ahead to find the gradient of the tangent here. So let's pick any 2 points. Let's say I'm taking this point, and this point. Let's call it A and B. Okay. Now if you remember very well, the formula for the gradient of a line is equal to M is equal to y2 minus y1 over x2 minus x1, which is still the same thing as the change in y over the change in x. Alright, so how do we now determine our y1 and y2, x1 and x2? It's simple. Now let's imagine that we have a number here. Let's say we have a number here. Let's say this is 2. Okay, of course, you know from our tutorials on function, if this is an input value, we should have an output value here, which let's call this, let's say this is 1. Okay, so we'll take the next point here, which is point B, and trace it down to our x-axis. Let's call this 5. Of course, you know it must have a corresponding output somewhere here. And let's say this is 3. So in that case, if this is x1, this has to be y1, the corresponding output. If this is x2, this has to be y2. And therefore, using this formula, the gradient will now be equal to y2 is 3 minus y1 1 over x2 5 minus x1 2, and we should have 3 minus 1 2 over 5 minus 2 3. So this becomes the gradient of the line AB. Now assuming we don't have any value here, so let me clean this off. 2 and 5, 1 and 3. How do we get the gradient of this curve? It's simple. So if this is our x value, remember we don't know what the x value is, so let's just call it an x value. What do you think the corresponding output will be? The corresponding output will be what? F of x, because it's a function, right? Remember, input and output. We've done this tutorial on functions, so you can check out the tutorials on functions under the playlist Introduction to Functions on my YouTube channel. And so if this is x, we have another value here. Now, so how do I get the next value of x here, which will give us our x2? Now let's pause for a while and think about it. Remember, initially I said that x is 2 and x2 here is 5. So what is the change in x from 2 to 5? Of course, we know that is 3, because 5 minus 2 will give us 3. Or you can say, to go from 2 to 5, just add 3 to 2 and we're going to have 5. It means that if the distance between this and this is given as the change in x, right, the next value here is going to give us what? X plus the change in x. If this is not clear, let's go back to analogy on 2 and 5. So if I don't want to write 5 here, I can simply write what? 2 plus 3, and it will give me 5. And that's the same thing I did here, because I know that the distance from this point and this point is change in x. So to get the next point, I simply have to add x plus change in x, and I'm going to have x plus change in x. Is that clear? And so this point plus change in x, what do you think we should call the corresponding output? Your guess is as good as mine. It's going to be f of x plus change in x. This will give us the output here. It means that x plus change in x is the input value, and f of x plus change in x is the output value. You can always check the tutorials on functions where I've explained input and output values in a function. So with that, we've gotten our x1 and our x2, our y1 and our y2. So we can now go ahead to find the gradient of the curve at point P. So we can say that change in y over change in x, which is the gradient, remember m is given as change in y over change in x, will be equal to y2 minus y1. So what is y2 in this case? Y2 is what? F of x plus change in x, minus y1 is what? F of x all over x2 minus x1. Of course, we know x2 is what? X plus change in x minus x1 is just x. So this is what we'll have. And then we can simplify this expression further by saying that change in y over change in x will give us what? F of x plus change in x minus f of x. Now x minus s will cancel out, and we just have change in x. Now don't forget that initially when we took 2 points on the curve here and here, it didn't give us the exact value for the gradient. And so remember what we did? We simply reduced the distance between these 2 points until it got to one single point here, P. So what does this imply? It implies that the gradient of the curve at point P is given as this expression we have here as change in x tends to 0. Remember, we reduced the distance of these 2 points until it became 0. That means the distance between those 2 points became 0. And that's why we have to include that change in y over change in x, taking the limits as change in x tends to 0, will give us f of x plus change in x minus f of x over change in x. So this expression will not be complete until we've indicated that we are taking the limit of change in x as it tends to 0. Now this entire expression is what we call differentiation from first principle. In other words, this is how to differentiate any function with respect to first principle. Now if this entire concept looks confusing to you, I understand. All I just need you to remember is that to differentiate any function using first principle, you have to use this particular formula. Just have to remember this and you are good to go. So in the next segment of this tutorial, we'll be looking at how we're going to apply this particular formula to differentiate any given function using first principle. Until then, thank you for watching and I hope to see you in the next one.